Alright, so today we'll be talking about the complex plane and polar form of complex numbers. But before we get there, solving equations with complex numbers is actually, it sounds like a daunting task. So like for example, if I asked you to solve, let's say 3x minus 2y plus 5i equals let's give it 10 plus 2xi minus 4yi. Okay, something that looks like this. It looks pretty scary. But if you just look for the parts that are equivalent, like for example the real parts, and then have that be one equation. So we would set it up as 3x minus 2y equals 10. Okay, that would be one equation. And the other would be the imaginary part. If you notice, if I got rid of the i's, okay, that would be definitely a problem. So that would be 2x minus 4y equals 5. Okay, and then I solve those two equations. Alright, I could actually find x and y, and you could actually just find x and y really fast by using that method. It's a wonderful method. It just makes sense. You just have to factor out the i's here, and then just treat these as two separate equations. You can find the x's pretty easily. Okay, so let me see if I multiply this by -2. Okay, I would get negative 6x plus 4y equals negative 20. Okay, and then I add those two together and I get negative 4x equals negative 15. So x would equal negative 15 fourths. Okay, and then you plug that back in and you'll be able to find it. Okay, and I incorrectly made the assumption that that's negative 15 fourths. That's just 15 fourths. Okay, so this should become 45 fourths minus 2y equals 10. Okay, now we minus that to both sides, and that should be negative 2y equals, let me see, 40 minus 45, that should be negative 5 fourths. And then I times both sides by, or divide both sides by negative 2, and so y should equal 5/8. And voila, you have both of your answers, given that the problem started out in in a complex form. If you just paired up the sides, you did factor by grouping, you should be able to get this pretty easily. Alright, so the complex plane is going to be a lot like the coordinate plane, the Cartesian coordinate plane, in that it has two axes, except in this case it's going to be a real number axis and an imaginary number axis. And when you're graphing a point, you're going to actually go to the right on the real axis and then go up and down for the imaginary axis, and there's your actual point. So this would be a plus bi. Okay, now it's also known as the Argand plane, so that's kind of cool knowledge to know. Okay, and let's start doing some definitions. Absolute value of a complex number. Guess what? We're dealing with our good old friend, the right triangle. So if we use Pythagorean theorem, we should be able to find it. So if z is our complex number is equal to a plus bi, then the absolute value of z, or we could also call this magnitude, alright, is going to be equal to the square root of a squared plus b squared. Okay, and that's its distance from 0, or the actual 0 on here. Okay. Alright, so let's start looking at some different stuff here. Alright, so now here's the rectangular complex plane. Guess what? It looks a lot like something we could do with polar. Okay, so if we wanted to represent this as r comma theta, okay, we definitely could. Theta would obviously be this angle right in here. Now, would not be unique, so we could actually represent theta as equal to theta plus any 2 pi k. Okay, so we could just represent it like that. So that's kind of cool that we could have that angle, because you could go around again, it would be the same, round, 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 round it goes. Okay, now r would obviously be the absolute value, or in this case we would call modulus. Okay, so the modulus will be r, or the absolute value of our actual part. The angle is called either the amplitude or argument. It's up to you how you want to call it. So this would be theta. Okay. All right. Now we're going to talk about this shorthand form real fast. Okay. All right. And we're going to prove it real fast by setting up the formula. So z equals a plus bi. Okay. So that is our rectangular form. Okay. But we can also replace a with r cosine of theta, and we can replace b with r sine of theta. Okay, and so this becomes z equals r cosine of theta plus r sine of theta times I. Okay, so I have that right there. Now if you notice, they both have an r, so I can factor an r out, and so I'm left with z being polar. So we can set it up like this: r times cosine of theta plus, and you could change the I in front and go I times the sine of theta. Okay, and this would be z polar. I would put a p for just polar. Just put a p. There we go. Okay, so z polar would be this. Now, shorthand, that gets long to write. This takes a long time to write. So shorthand is r times CIS. The C stands for cosine, the I stands for the imaginary number, and the S stands for sine. So whenever you see something, you can just rewrite it as r CIS theta and just have it be represented right there. Alright, let me show you how. Okay, so for this bad boy, what we're going to do first is, this is 2 plus root 7i. This is rectangular form. So what we're going to do is we're going to convert it first to complex, or sorry, polar. Okay, so we're going to do the square root of, let me see, that would be 4 plus 7. So that would be root 11. Okay, so r would equal root 11. Something pretty simple as that. Okay, now in order to find the actual theta, okay, we would need to do our rule again. Now in this case, it would be theta would be 233 equals arc tangent of not y divided by x, but b divided by a. Okay, and if a is negative, we would add, we would definitely be adding 180 or pi. But in this case, a is not negative, so we're just going to go ahead and do it as is. So this is going to be root 7 divided by 2, and we use our calculator real fast. Okay, and this will actually be either, it depends on if you're using radians or non-radians. This would be 0.92 radians, or let me see, what is that? 52.91 degrees. Okay. All right, and that's going to be set up that way. Now that we know what theta and r is, we could actually set this up. That this in polar form, so this is going to be polar complex, is going to be equal to r, which is going to be root 11, so root 11 CIS 52.91 degrees. Okay, or you can just say the radians too. So I'll just use radians, 0.92 rad. Make sure you say rad, of course. All right, that's it for converting complex numbers into polar complex numbers. I'll talk to you later. Bye.